Please welcome to stage Felix Orgenstein, IBM Client Engineering AI Engineer and Customer Care, Dr. Kanishk Chaturvedi, Software AG, and Keshav Kumar, Global Ecosystem Manager, IoT Software AG. You can't get enough.
So hello everyone, welcome to our presentation. I'm Keshav Kumar. So I'm responsible for strategic IoT partnerships at Software AG, and in this case also leading our partnership with IBM globally. So we are here today to talk about IoT use cases and how generative AI can add value to our customers when it comes to IoT. I don't know how many of you are in this IoT space, but we are one of the leading IoT platforms. You might have heard of Cumulocity IoT. And we certainly operate in this area. And for us, it was really important that we see how we can add value to our customers when it comes to generative AI. So, yeah. So, to start the presentation, let us imagine a situation, that you with your family is gearing up on Christmas Eve to celebrate Christmas Eve, and there is a power outage, and the light goes off. Not a very 21st century, it doesn't sound like a very 21st century scenario, right? But this is happening very increasingly all across the world. For instance, in December 2022, in Australia, in Western Australia, very similar instance happened, and there were more than 100,000 households which just went out of electricity. And similarly, in the UK, one of my colleagues 2 days back was telling me they had similar situation in the summer when there was a peak summer. So again, doesn't sound like a very 21st century situation when we are talking about generative AI. So how do we at Software AG, together with IBM, see this? We will be talking about it. But what is driving this? What is happening here? We have huge electrification happening all across the world because we want to meet our climate targets by 2050, which is causing massive changes to electricity grids across the world. And here, what we need to do is to proactively manage such power flow bidirectionally. And as you can see on the right side of the picture, on the high voltage load side, electricity utilities are quite in a situation to control such a situation. But when it comes to low voltage, it is very difficult for them at the moment to getting a hand of it. And what it requires now, what we kind of agree on, the kind of solution, what needs to be in place, kind of holistic and transparent solution, it requires a very highly flexible data acquisition solution, which can specifically focus on these low voltage scenarios, situations, wherein we are able to connect with multiple set of sensors via multiple protocols, and we are able to get this data and also consider a lot of data sets which should ideally be part of our data acquisition. And then this data can be then fed into AI models, which then can help us to predict such a situation. And it's not only this technological evolution that can support us, but at the moment, regulatory forces are also pushing utilities to react. For instance, just this year, Germany has now a regulation which is asking utilities to react in just 3 minutes when such situation occurs. So it's a big opportunity for us and also the modernization of such grids across the world. So what are we doing together with IBM? So IBM obviously had a leading generative AI platform. You are hearing probably about this since morning, and obviously you know. And we, as IoT platform player, come into this together, and then we created a solution together with our partner, IBM Consulting. What we did is basically built an AI model, which this whole IoT dataset is feeding into, and then this model is able to predict such a situation, which gives these load managers, these frontline workers, time to react and manage such situations. But how about generative AI, where this sort of thing comes in? So we have a chatbot which has been integrated into our platform, and then this chatbot can a load manager can use this chatbot to query whole lot of operational IoT data, to get guided recommendation, operation recommendations, suggestions, and so on. And this augments their task and make them help them and make them more productive, so to say. And this is what all about what we have done. But the last part, what I just mentioned regarding chatbot integrating these machine learning models, this is the area where we see the convergence of IoT and generative AI. So these are the 4 low-hanging fruits, or let's say areas, because in the morning I was in the presentation and I saw an IBM executive asking how many of your customers are asking about generative AI or looking at generative AI. There were many hands. But when he asked about how many are actively doing something about it, there were very few hands. And this is where this topic becomes really, really important, that which are the convergence areas in our specific industry in case of IoT. And these are the areas which we figured out. And out of 4, we will not only tell you, but today we will show you that what we have achieved in terms of these 3 areas, the 1, 2, and 4, we will show you today as part of our demo that we have achieved as part of our solution. And at the moment, we are offering the solution in the market. So some of you might not be knowing about Cumulocity, but we are one of the world's leading IoT platform. And available as to cloud. We are cloud native. We can scale. So just for instance, half of the wind turbines in Germany are connected to Cumulocity, and there are many such examples, millions of escalators, elevators, whatnot. So we really manage a very, very complex machines, set of machines with very complex sensors and data sets. So we can connect across various multiple protocols. So some estimate is something between 300 to 400, which is quite a huge. And also in the areas of utilities, we have a buy and build strategy. What it means is basically we provide a very low-code, no-code kind of platform, which is very self-serviceable, so you can go to the market very fast. And we have very advanced device management capabilities when it comes to firmware updates, software updates, having bidirectional communication with your devices and so on. We are very, very good at it. And it's not only me saying, but all the analyst reports we look at, we are considered to be the best in it. And we support our solution across the globe, including in China. So you would say, Keshav, okay, all this you said about Cumulocity, I mean, it's fine, but many of competitors also say it, but you can go to the analyst reports where you can see that we are really world's leading IoT platform. So we ranked with Microsoft in the leaders quadrant in Gartner. On the vision side, we are even ahead Microsoft. So in Forrester Wave, in Mach Nation, so all the analyst report you will see we are the world's leading IoT platform. So with this, I will hand over further to my colleagues who will provide you better understanding in terms of architectures, and I will also show you the demo, so the real technical part of it. So what I just spoke, they will show you how they did it. So Kanishk.
So thank you, Keshav, and hi, everyone. I'm Kanishk Chaturvedi. I'm a solutions architect at Software AG. And in the next few slides, I would like to talk about some of the technical details that we have been working together with IBM watsonx team. So to begin with, this is the high-level overview of Cumulocity integration with watsonx. And basically here, when we first started working with IBM team, the most significant advantage that we observed with watsonx is that it is highly modular in nature. So that means we can use it for different purposes, for different use cases, and depending on those use cases, we can plug and play different types of large language models and so on. So as an IoT platform, we started working on designing this high-level overview vision, where we wanted to embed this watsonx chatbot within the Cumulocity IoT interface, so that the same chatbot can be used for different scenarios. So for example, using Discovery API web crawl, the chatbot could be trained over our publicly accessible user guides, concept guides, tech community discussion forums, articles, blogs, and other things. Similarly, using the right machine learning connection, the chatbot could be used to interact with machine learning models or predictive maintenance models. Similarly, in the future, using the code assistant, the same chatbot can also be used for code generation or code reviews. For example, formulating right API queries for communicating with the IoT platform. So in the past few months, we have been actively working on realizing the above 2 scenarios. that is chatbot for user guides and concept guides, and the chatbot for machine learning models. And in this talk, we would like to share some of the early results with you all. So let's begin with the chatbot for machine learning models. So what exactly do we mean by this? So here in this exercise, we wanted to see how a large language model can act as an interpretive layer, which can explain raw prediction results in simple and natural language. So these type of chatbots basically offer more clarity and better actionable guidance for users, field workers, load specialists, and so on. So where can these chatbots be used? So they are highly relevant for predictive maintenance or prescriptive maintenance scenarios, computer vision or image classification scenarios. Similarly, in the scenarios of time series analytics, time series forecasting, anomaly prediction, and so on. And from the technical point of view, these machine learning models can be developed or deployed using different frameworks. So for example, machine learning models can be deployed using Maximo application suite, Watson Machine Learning Studio. Similarly, the machine learning models can also be developed using classical open source machine learning frameworks such as TensorFlow, PyTorch, Onyx runtime, and so on. So our architecture basically ensures that the chatbot can be coupled with any type of machine learning model deployed on any of these machine learning frameworks. So before we show the live demo, I just want to talk about quickly on this particular use case from where we took this inspiration for developing the chatbot for machine learning models. So as Keshav in the beginning mentioned about this joint activity with IBM, which we are working on, which is about integrated load management solution, ILMS, which is used or focused on grid modernization. So as you can see, the architecture on the left-hand side, we are using Cumulocity IoT to capture real-time or live streaming data from different devices and sensors, such as smart meters. Now, this live streaming data can be managed using Cumulocity's inbuilt operational store. And similarly, the data for larger intervals can be archived using Cumulocity's inbuilt data lake functionality, which is called Data Hub. So now, once the data is managed, the historical data from Data Lake, for example, can be used very efficiently by Watson X to train their machine learning models on. Similarly, the live data managed in operational store can be used for performing inferencing on an already trained machine learning model in Watson X. And similarly, this combination of regularly updated streaming data can be used for enhancing the machine learning model that is already trained over Watson X, for example, using right MLOps lifecycle. And now, using Watson X, so Watson X LLM or NLP capabilities can provide a layer on top of this workflow, which can basically be used by users to communicate with these machine learning model results in simple and natural language. So that is exactly the inspiration for us to start with this chatbot for machine learning models. So for example, here you can see that we have a chatbot which is embedded inside the Cumulocity interface, and it can be used for communicating with different types of machine learning models.
I think that's
So now, in order to talk more about this architecture, I would like to invite Felix.
all right. Yeah. So thank you very much, Keshav and Kanishk. And hello from my side. I'm Felix Augenstein. I'm part of the IBM client engineering team, and I work there as an AI engineer, and very happy to be here today and to present you this awesome use case. Yeah. So let's dig a bit deeper into the architecture for the machine learning use case here. And as you can see on the left-hand side, the chat interface with our Cumulocity IoT assistant. If you put in a query here, right, you ask a question, this query then gets sent to our Watson Assistant service or to the API. And from there, it's forwarded to the machine learning middleware. And the machine learning middleware then can access several software solutions. So it can go to Watson Machine Learning, to IBM Maximo, and to any other ones, right? And from that, it extracts results. It gets some kind of prediction. And that is then sent again back to Watson Assistant API. Now, on top here, it says near completion. We don't have the ML middleware at the moment running. We have the kind of prediction result. So imagine this as a JSON document. We've got this static inside our assistant solution. But the other part, the more important part, the large language model solution is actually already in place, right? So what happens then is that the assistant sends the result in a prompt, right? So we got an instruction in the beginning, then we have the result from the machine learning API, and then we have the initial user query, and we send all of that to the large language model that is part of our WatsonX.ai platform. And there we generate an answer with different large language models that you can use. In this case, we are using Meta's Llama model. We can also switch to IBM Granite. We can also use other models, right? So the platform is very, very modular. By just changing the model ID, you can use different models. So then we generate the answer, and we send back that generated answer to the Assistant API and forward it to the chat. And as the user, as the power load manager, for instance, you see this nice output. So a lot happening in the back, and really cool experience here for the user, right? There are, of course, now some example queries and endless possibilities for the power manager that you can ask. Predictive maintenance queries, right? So how likely is it that the power load peak will occur next week? And can you tell on which days? Also prescriptive maintenance queries. What are the consequences of something, right? For instance, for the network, if I accept the peak load here, and some other questions, right? Nicer to see this afterwards in the actual live demo. Going to the second use case, right? So the documentation guides looks kind of similar, right? But there are actually some different things how you implement that. And this architecture here can also be called RAG. So maybe some of you heard that already. So retrieval augmented generation, that stands for, right? And what happens here is that, again, you are in the chat, you put in your query, and the query gets sent to Assistant. So up to here, it's the same thing. But then we forward it to Watson Discovery. And Watson Discovery is kind of a software for intelligent document management. And what you can do with it is you can connect it to your knowledge base. So basically, you can bring your own knowledge base. In our use case, it's the Cumulocity user guide plus the so-called tech community, kind of like a forum where you can read through blog articles and so on and so on. And Discovery then uses the query and extracts a response in form of text snippets, right? So it can, for instance, return, let's say, 3 text snippets and say, hey, somewhere here in these text snippets, there's the answer to your initial query. And then what we do is, the second part is similar. We use WatsonX.ai and large language models and put this again into a prompt, right? So there's an instruction. Then instead of the machine learning result, the prediction, we put in those text snippets from Discovery and the initial user query again. And this prompt goes to the large language model, and then we answer the question, right? We generate, again, an answer, gets sent to Assistant, and then gets displayed for the user, right? So this is our RAG architecture. I've actually never seen the first use case, so maybe us, IBM, and Software AG, we should invent a name for that. Machine learning augmented generation or something like that. I think we're the first ones who are doing this, right? And again, endless possibilities, lots of queries that you can ask. Foundational knowledge, right? Can you explain something? For instance, the domain model of Cumulocity IoT, troubleshooting things, right? I get this kind of error. How can I fix it, for instance? Other advanced functionality, tech community insights, right? So you can go to the Assistant and ask, for instance, what are some trending discussions related to security on the platform? Things like that. Now, it's always nice to see these queries and examples on slides, but it's always nicer to see it live and in action. So with that, I would say let's go to the live demo and take a look how this performs. And for that, I will go to my laptop. And yeah, it's appearing very nice. All right, so imagine you are the power load manager, and you log into Cumulocity IoT platform, right? What you see here at first is the so-called cockpit application, so the point where you start. And as you can see here on the top right, we are now logged in with Kanishk's account, actually. And on the lower right part, you can see here, hi, I'm a virtual Cumulocity assistant. How can I help you today, right? Already greeting me, very nice. And now I can launch that. And there are already some buttons that I can click, so I will just go with the first one. And what is Cumulocity IoT? That actually triggers our documentation use case, right? So the retrieval augmented generation. First part is discovery, and it goes to the knowledge base. And then with these text passages, we generate that prompt and send that to the large language model, and then it generates an answer for us. And as you can see here, based on the provided documents, it explains to me what Cumulocity IoT actually is. And it even gives me the documents where the large language model based its answer on, right? So now, if I want to go through the documentation again and read through it, I can just click one of these links. And as you can see in the lower part here, it will send me then off to the guide where I can read it a bit in further detail, right? So let's continue. Please explain how to create a dashboard in Cumulocity, right? And please explain how to create a dashboard in Cumulocity is again the same use case, right? So it also goes to the documentation, the retrieval part, formulating the prompt, and generating an answer for me. And whenever that answer comes up, here it is. Sure, I'd be happy to help. To create a dashboard in Cumulocity, you can follow these steps. And it even lines out these nice steps here in an ordered list for me, so I can go through that. I can now log in with my Cumulocity account, navigate to the Dashboards tab, click Create a Dashboard, choose a template, and so on until I save and publish my dashboard. Really cool, right? Really awesome. And if I want to go through the documentation, I can do that as well. Now, let's continue. Can you give an overview of Data Hub? And here, I actually have to mention that we had some troubles, right, with these two words, Data Hub, because in the documentation, Data Hub is spelled together, and it's actually a feature. So for the retrieval part, we had some issues that we didn't retrieve the correct sources, right, the correct documentation, and the generated answer was also not ideal, right? And we could solve that within Watson Discovery by teaching it about synonyms. And we did that by using so-called query expansions, where we basically tell it, hey, whenever the user types in Data Hub as two separate words, he or she actually means Data Hub spelled together. And this way, we could retrieve the correct source and improve the answer a lot. And look at the answer. Sure, I'd be happy to provide an overview of Cumulocity IoT Data Hub. So it already knows, hey, you're talking about Data Hub, the feature, right? Let's continue and ask it, can you predict the day with the highest power consumption next week, right? So this now being the machine learning use case, right? As you know, we don't have that implemented yet, but the result basically as a JSON file is inside the assistant, and the large language model part is actually, that's the part that is working, right? And as you can see, it really can interpret this JSON data that comes back and tells us, yes, so based on historical data and trends, it appears that Monday, and I think we actually had two Mondays in there in the prediction. So the first one is the one with the highest power consumption, right, with a predicted load of 110 and so on megawatts, right? And let's continue and ask another question. Can you find a difference in power load during the week and for weekends? And again, the machine learning use case. And what comes back, as you can see here, yes, there seems to be a pattern in the data, where the power load is higher during weekdays than on weekends, right? And even some more information. And if you would take a look at the data, that is actually correct, right? So it's able to interpret the data in a correct way and gives us the result. And let me even show you another cool feature. If I just slightly change the input and say, and why, if you remember chatbots that we've built, let's go only 1 year back in time. You would have an intent recognition, right, and a kind of hard-coded result. So these two inputs here that are very similar would always trigger the same thing. Not with GenAI, right? Here it's actually able to understand that input and what I'm asking about and why is that the case. And as you can see here, the output is different and actually answers my question, right? So it says again, yes, there is a difference. What is the difference, right? That it's generally lower on weekends compared to weekdays. And then it answers the and why. This can be attributed to the fact that most commercial and industrial activities take place during weekdays, resulting in higher power consumption. So really awesome, I would say. And yeah, I don't know, guys, anything else that we should ask here?
Yeah, I think
Any
this is
suggestions?
quite a very good example in showing how a generative AI or large language model-based chatbots can communicate with the results of machine learning models. Maybe I'm also very curious if I'm a power load specialist, can I ask some question which can be used for getting the insights or guidance from this chatbot? So maybe for me, can you ask, what is the biggest consequence if I accept the peak power load?
Like this?
Yeah.
All right. And it gives an answer. Are you satisfied with it?
Yes.
Yes?
So it actually can show us that this will be the consequences if you do, if you don't take action on time. So I think this is also a very good example where this chatbot can also be used for getting insights or for getting better actionable guidance from the results of the machine learning model. So
Awesome.
thank you, Felix.
Really cool. Thank you, Kanishk. All right. And with that, I would say let's take a look again at the slides, and over to you, Keshav.
Yeah, to just conclude, I mean, I think you enjoyed the demo part at least, which was quite fascinating. Yeah, to conclude, I would say this is coming off of two leaders in their own space, AI and IoT. And we sit down, we took our time, we understood some of the challenges, we find out the convergences, and now we have a joint solution built. And we feel that we are really moving ahead in terms of our motion and our, how our industry is moving. We are quite ahead. Our feeling is, together with IBM, and how, I mean, the kind of support we have got from our IBM colleagues, our partner colleagues. Many of you think that probably this partnership is quite new, but our partnership dates back to more than half a century, actually. Software AG is one of the world's first software companies in 1969 in the Beatles era when we were founded. And our database software still runs on IBM mainframe computers. So this is over a 50-year-old alliance, which is still running today. And we have now focused on energy utilities to begin with, where we saw a kind of an opportunity, what is happening in the industry, as I explained earlier. And two MVPs, what we have created, but we have further in our roadmap, especially as Kanish showed you guys in the area of code generation. So when IBM comes up with a solution, we would love to kind of investigate that. Yeah, so let's partner together also if you're interested in building such a solution where you see in the space of IoT that you could also have some ideas and can investigate something or kind of co-create something. Feel free to interact with us. Feel free to connect with me. I'm here, and thank you very much with this for your attention. Thank you very much.
All right.
Okay.